Hello, and welcome to the CSAIL Alliances podcast series. My name is Steve Lewis. I'm the Assistant Director for Global Strategic Alliances at MIT's Computer Science and Artificial Intelligence Lab, better known as CSAIL. In this podcast series, I will be interviewing principal researchers to find out what they're working on and how it will impact society. Today on our podcast, I will be speaking to Jacob Andreas. Jacob is the ex-consortium assistant professor at MIT in the EECS and in CSAIL. He earned his PhD degree at Berkeley, where he is a member of the Berkeley NLP Group and the Berkeley AI Research Lab. He earned his master's from Cambridge, where he studied as a Churchill Scholar, and his BS from Columbia University. He has been the recipient of an NSF Grant Fellowship, a Facebook Fellowship, and paper awards at the NAACL and ICML. His research focuses on building intelligent systems that can communicate effectively using language and learn from human guidance. Jacob, thank you for your time today.
Thanks for having me.
Can you tell our listeners a little bit about the focus of your research and some of your bold aspirations or goals?
Broadly, my group works on natural language processing. So basically, anything you want to do with a computer that has language as input or language as output, we are interested in. And in terms of, I guess kind of broad aspirations these days, I think there are really two pieces to the story. One is building NLP tools, building language processing tools that work for all of the world's languages and that work especially in languages where we don't have huge amounts of labeled data. So right now the kind of NLP toolkit works really well in languages like English and Chinese, where there's been a huge amount of research effort and where there are a lot of specialized resources available already, and not so well in most of the other languages that people speak in the world. And so one thing that we're really interested in is doing more with less data, especially with the long-term goal of making NLP work for everybody. Another big research aspiration that we have as a group is using language, sort of enabling the use of language as a general purpose tool for building machine learning systems, right? So right now, it's still the case that the main paradigm for training, any kind of intelligent model, any kind of automated process is basically to collect a bunch of examples of the thing that you're trying to do and show the model a bunch of those examples and let it just learn from example. But if you think about how you acquire a new skill, right? If you're trying to learn a new recipe, learn how to bake a cake, say, you don't do this by watching a million videos of people baking cakes on YouTube. You go out and read a recipe and maybe, watch one or two people baking a cake. And so there's a lot that we can learn about complicated tasks and about new skills in the form of language. And so a lot of what we do as a group is aimed at making language sort of available to the rest of the machine learning world as a teaching tool and as a training tool.
So can you tell us about the current state of spoken language or natural language processing?
Yeah, well, so for spoken language processing, Jim Glass at CSAIL is probably the local expert, but we're actually starting to get interested in some speech questions these days too. And I think the big thing that's happened, and really the big thing that's happened in natural language processing generally in the last 3-4 years is a real shift to focus on what's called unsupervised pre-training of models. So in fact, rather than getting a bunch of sort of labeled data for the specific task that you're trying to do, we now have reasonably effective kind of general purpose methods that can, you just give them a bunch of sort of untranscribed speech even or unlabeled text, and they can extract from just like big collections of text corpora, a lot of information about how language works and sort of what individual words look like and the relationships between individual words, that then allows you to do downstream much more complicated things using relatively small amounts of labeled data. And so coming back to what we were saying before about making NLP work for low resource languages, this kind of unsupervised learning, this kind of pre-training is really important there because often we still, do have access to lots and lots of text or lots of speech, and it's just these kind of special labeled data sets that we don't have access to.
You had mentioned about training data, and how we do it today in machine learning and deep learning is we have images and we have human labelers, or we might use synthetic data to label it. So your concept is to use speech to label the data, and to use less data, to not to have 10,000 images or 100,000 images to label. You want to get it down to being able to speak in order to train the model.
Right. I mean, that sort of, I guess more generally, if I have some task that I want a model to be able to accomplish, one way to specify that task is to say, here's a gajillion inputs and a gajillion outputs that sort of exhibit the specific kinds of predictions that you're supposed to be making. But another way, in the context of something like image classification, is just to say, I want you to build me a classifier for this bird species. This bird species is characterized by having, a red head and brown bars on the wings. And in that sense, a couple of words can be worth a million pictures if you already have the right language for describing the kinds of things that you want your model to do.
I see. And why is explaining deep neural networks so hard, so difficult?
Yeah, well, and this actually ties into another sense in which we can use language as a tool for sort of helping the rest of the machine learning ecosystem. But so why is explaining deep networks hard? Well, if you think about a task like machine translation, say, where I have an English sentence and I want to turn it into a Spanish sentence. The most kind of naive description of how current models solve a problem like machine translation is you represent an English sentence as a list of numbers, you multiply those numbers by a bunch of other numbers, you throw away the negative numbers, you multiply them by a bunch more numbers, you throw away the negative numbers, you do this 5 or 10 times, and what pops out at the end is a different list of numbers that happens to represent your input sentence in Spanish. And right, that's like totally opaque and very, very difficult to understand as a description of what this model does. It gives you very, very little insight into how machine translation is working, how it's actually possible to do any of these things. And I think this was actually a large part of the reason why the machine learning community sort of took so long to, or the mainstream part of the machine learning community at least, took so long to hook into all of this deep learning stuff, is that it's not clear that that process is actually capable of doing machine translation at all, right? That there's enough structure in just like multiplying a bunch of numbers together to do something as complex as translation. But one of the really surprising things that we've found in the last couple of years is that there is a lot of structure in that process at all, right? So if you look in the middle of some sort of deep neural network that's implementing a translation model, say, you can, some of these numbers that show up in the middle are actually meaningful, right? That tell you whether your sentence that you're trying to translate is in the past tense or the present tense, or whether the subject of that sentence is plural or singular, or, whether the sort of, event taking place in the sentence is an eating event or a drinking event or a running event or whatever. And so the research question then becomes, how can we actually figure out what parts of this computation do things that humans can understand, right? How do we identify those particular numbers in this large collection of numbers that are getting generated in the translation process that actually correspond to things that people have names for and that you could sort of hook onto as a way of explaining what it is that these networks are doing. And so one of the sort of insights that we've had as a group in the last couple of years is that you can think of these lists of numbers that the models are producing as intermediate processes or intermediate products of something like a translation process, is that these constitute a language of their own, of a kind, right? That you can think of what this neural network is doing as taking an English sentence and not turning it directly into a Spanish sentence, but instead taking an English sentence, turning it into a sort of Neuralese sentence in some kind of Neuralese language, and then translating that into Spanish. And what's important there is that you can then use all of the tools that we have for translation and apply them directly to that Neuralese language to help us understand what's actually going on inside these models. And the most surprising thing is that this actually works for tasks other than language processing tasks. So you can think of an image classifier as having its own sort of Neuralese language internal to the network, where it's saying, here are all the things that I see in the image before making a classification decision. Models for other NLP tasks as well, produce the same kinds of representations. And what this means is that if we want to explain even what's going on inside something like an image classifier, or inside, some sort of like distributed multi-agent system where the agents are communicating with each other, that we can explain all of these things by thinking of the explanation problem as a translation problem and generating natural language descriptions of what it is that's going on inside these models.
I see. And can you tell us why current machine learning techniques fall short of human abilities to learn language and to learn from language?
Yeah. So there are two, I think, well, there are a lot of really remarkable things about human language and human language use. But there are two that I think are really, really important in the context of current machine learning models. One is that people are really good at understanding the meanings of sentences that involve words that they've never seen combined together before, right? So if I tell you that I'm imagining a plaid elephant sitting in a teacup, you have never heard all of those words together in a sentence before, but you have no problem at all forming a picture in your head of a plaid elephant sitting in a teacup. And so people are really good at sort of composing words and composing meanings to build new meanings that are really like completely novel. The other thing that people are really good at is learning new words very quickly from a single exposure. So if I tell you, I'm about to dax once, and then I go, I can't make a whistling noise, but like, whoop, you already know what DAX means, and you figured it out. And if I ask you now to DAX 3 times, you'll know exactly what to do and what that means. And the important thing there is that for all of their current effectiveness, standard, machine learning models generally, but I think neural network models most acutely just cannot do this well at all. That they need many, many, many examples to learn new words, and even more examples to figure out how to use those words in contexts that are different from contexts that they ever saw before. And so one thing that we're spending a lot of time thinking about as a group, and actually in a project that was sponsored by the Machine Learning Applications program from Alliances, is building sort of new kinds of neural language processing models that maintain all of the advantages and the sort of flexibility and expressiveness of current ones, but that are also able to effectively do this kind of few-shot learning that we've been talking about, and also sort of compositional language understanding, and understand what happens when new words get put together in new ways.
That's great. You had mentioned the machine learning applications, strategic research initiatives that you're involved in, and we have a few other initiatives at CSAIL that provide funding for this kind of leading edge research. So glad to hear that you're participating in that. Can you talk a little bit about the problem of bias in machine learning models?
Yeah. So coming back to what we were saying before about big data sets, like the models that we have now need lots of data. And it turns out that good data sets are very hard to create, right? And that if you're collecting, for example, a set of example sentences that you're going to use to train some kind of NLP model, it's actually quite difficult to gather a set of sentences that are going to talk about, all of the things that anyone in any part of society in any part of the world are going to want to talk about. And it's very easy to, if you set out to collect a new data set, to build a data set of sentences that talk about the kinds of things that MIT graduate students know about and like to talk about. And so the community spends a lot of time thinking about design of models, and I think not nearly enough about the design of data sets. And one thing that I think is generally happening, and that's really exciting to see happening, is that focus is starting to shift, and especially to think about things like the sort of social processes that underlie data set design, and the ways in which we evaluate machine learning models and figure out whether they're safe to deploy or not. And that these kinds of conversations are finally being given kind of a central role in machine learning. One important caveat there is that bias is not just a property of data, right? It's also like very much something that can be introduced by or amplified by sort of concrete modeling decisions. I think we now have reasonably good evidence in the machine or in natural language processing in particular, that even just like some of the model architectures that are best studied work better in English than in other languages due to sort of particular structural properties of English. And we can imagine a different world where everybody's using a different class of models because English wasn't the language that we were using as the kind of main benchmark for deciding what parts of the space of possible research projects is worth exploring. But even here, when we talk about issues that are really specific to model design, having better data sets, having more representative data, I think will make it easier for us to build tools that identify these kinds of problems in models as well.
I see. Can you talk about the relationship between language and vision, specifically as it relates to AI or machine learning?
Yeah, so, certainly it is the case that like when people learn words and when people learn language, they're learning from a lot more information than just the words that are being presented to them, right? That you're in kind of a social context, you hear other people speaking, you're aware of the things that they're interacting with. For people who can see, for children who can see, a lot of their learning of word meanings involves visual stimuli of some kind. And this is something that we're really not, I think, exploiting as fully as we could be in NLP right now. And so I think one of the big open research problems is how to use information from vision to help us build better models just for language understanding and to sort of more efficiently learn how words mean by using training data and training paradigms that really kind of put those things in some sort of context that grounds out in the real world. But this also goes both ways, right? And so like we were talking about before, there's a lot of information about how the world works and what objects look like and how objects interact with each other that is locked up in language. And that one could learn just by reading a bunch of books once you sort of have some basic understanding of how language works. And so if we could get this information out of text, it would be much easier to build vision models that learn, for example, how to classify some new kinds of objects just based on their textual descriptions in a way that would also allow us to build more robust or more general vision systems. And one of the cool things about this kind of embodied intelligence research community that I'm in at MIT is that everybody's working on the boundaries of these problems. So we're doing a bunch of language and vision stuff. We collaborate with a bunch of vision people who do languagey kinds of problems and collaborate with, roboticsy people who work on language and roboticsy kinds of problems. And I think what everybody here is working towards is models that really have sort of general purpose concepts and general purpose reasoning skills that you can both learn from any kind of supervision, whether it's language or whether it's vision or whether it's action, and similarly apply to any of those kinds of problems.
So let's talk about the social and ethical use of NLP. For example, how can NLP be used to combat hate speech online?
Yeah, that's a great question. So certainly it is the case that one thing we can do with NLP tools is just sort of generally to help people communicate more effectively with each other, right? And so a big part of that is online communication, using NLP to do things like filtering hate speech, like identifying misleading news or other, sort of problematic sources of information online. And I think it is certainly the case that the models that we have right now are like getting to the point where that actually seems like something that we could do in a way that might be effective enough to actually deploy in the wild. The flip side of that, of course, is that we have to make sure that these NLP tools themselves are actually being deployed in a way that is ethical and conducive to good online communication. Hate speech is an especially interesting example because there was some work from the University of Washington a couple of years ago showing that standard hate speech detectors themselves have all kinds of problematic biases baked into them, and that they were like more likely to classify, I think, tweets from Black Americans incorrectly as being problematic and to improperly censor them. And so the important thing is just that these tools really are a double-edged sword. And I think there's a lot of potential to do a lot of good, but this is one of the reasons that it's so kind of urgently important that we also figure out how to make these tools better at explaining themselves so that we can figure out when they're actually sort of robust enough and ready to deploy.
I see. Can you talk a little bit about your collaboration with one of our alliance partners like Facebook?
Yeah, so we actually just wrapped up a really fun project with a research group at Facebook, where so we've talked a lot today about language and vision and sort of using language to inform vision and vice versa. Another thing that we think about a lot is language and action and using language to sort of help people do things in the real world, or even maybe to scaffold, autonomous agents that can take their own actions. And so one thing that we've been looking at with Facebook is video games and building models that can actually more effectively play real-time strategy games with help from language. And we've shown that if you sort of train these things, not just on examples of people playing these games, but people playing these games while explaining, hey, here's the high level action that I'm going to take right now, or here's my long-term goal, that you can much more efficiently and much more effectively train models to play these games. And I think, this is both nice just from the kind of general scientific standpoint of showing that you can do this, but really concretely, maybe even for building, better, I guess in the short term, actual, better opponents and better players to play with in video games, but in the long term, for autonomy more generally, right? For building robots that can acquire skills quickly with help from language and things like that.
I see. So what is the future of NLP?
So many things. I mean, so like I was saying before, I think at least one big piece of it is taking over the rest of machine learning and really being able to use language as a kind of first-class tool for training models and explaining models and interacting with models. And then, also like we said at the beginning, I think the other piece of the future of NLP is making it available to everybody and taking the tools that we have right now that work really well in the kind of majority languages in the world and making them work for everyone and for all of the different uses that people want.
I see. Is there any other research projects that you'd like to talk about that you're working on?
So many things. I mean, we have work going on right now on sort of using language to help with programming and sort of letting you build programs with guidance from natural language, using language to sort of learn better libraries for solving other programming tasks in the future. We have a bunch of work aimed really at just understanding, like in a really precise way, what it is that you can learn from text alone, and when we train these models on these big text corpora, without information from vision or without information about action, how much are they actually learning about the underlying structure of the world? Anyway, we have some work on using language to do image synthesis, and imagine being able to talk to Photoshop to change the images that you're looking at or generate new images, and lots of other things.
Great. Well, Jacob, thank you very much for participating in this podcast. It was great to talk to you. If you're interested in learning more about the CSAIL Alliance program and the latest research at CSAIL, please visit our website at csail.mit.edu and listen to our podcast series on Spotify, Apple Music, or wherever you listen to your podcasts. Tune in next month for a brand new edition of the CSAIL Alliance's podcast and stay ahead of the curve.
Thanks for having me.
Thank you very much.